start button first.
Hi everybody, I'm gonna make a robot. It's gonna be nice.
Someday it'll be a robot. We're starting on page 1 here.
Yeah.
First, let's go through and make sure we've got all this stuff and we see what it is here. See, we've got the Super Starter Kit Uno R3 project. This little computer thing here. So, I'm gonna just throw it around and okay, so when you go through, you'll be able to not look at that and look at this.
Yeah.
Okay. Okay, so we go through, make sure we got everything. First thing on the list, Uno R3 controller board, one piece.
Yeah.
Okay, we got that.
We got that.
Let's see.
That piece. Let's see what it is.
There's a little check mark on there.
Is it this piece?
No, yeah. We'll just kind of grab and go like this. This is the prototype extension board one piece. See?
Ooh, I've seen these before in the video.
Okay, these are LEDs, 25
Yep.
pieces.
Yep.
We won't go through and count them. We'll trust it's 25. Let's see, what's this look like?
I don't know what's in that before.
We want to look at these pictures here and see if we. This looks like it's got multiple pieces in it, so we'll check that in a sec. We'll check that near the end. Okay, this is a USB cable. Okay.
Okay.
These are 65 jumper wires.
Holy cow, that's a lot.
Holy cow. There's a 3.6 volt motor. Nope, that's not 3.6. This looks like 3.6 and a fan blade that goes with it. Okay, here's the LCD 1602 module of pin header. So that means we don't have to solder. You'll learn what that means here in a bit. There's a
battery?
9-volt battery. Come on, and check it out. Ooh.
Ooh, remote.
Whatever we in there is going to be remote control. We'll check that off. Let's see.
Ooh.
These are resistors. 120 of them.
Holy cow, that's a lot.
Holy cow, that's a lot. This is going to be the cool battery with DC. So it's going to... There's some stuff here. It's just like a...
Joystick thing?
Yes, joystick module.
Hey, this right on there.
Joystick for potential robot.
Yep.
See, ultrasonic sensor. That's what this is called.
Oh, look at the ultrasonic.
Yeah.
That's the second word. It's sonic.
We'll learn. Let's see. Someone watching. It's our breadboard. It's called a breadboard.
Ooh, that's a silly name. Hit bread.
Breadboard. So,
Bread boy.
not boy, board.
Yeah.
This is a stepper motor driver board.
Yeah, it's cool.
Very interesting. this is the power supply module. So that's what we hook up so the power everything.
Yeah.
Here's some more display stuff. This is a 4-digit 7-segment display.
Wow. Look at this.
Those aren't stickers, those will light up electronically. It'll show you what number. You'll be able to see numbers on it.
Ooh, that's cool. Cool.
This is a male end, and this is a female end.
Ooh.
These are called female to male DuPont wire. There's 10 pieces.
Ooh, that's cool.
This
Another
shows
one?
one number. It's a 1-digit 7-segment display. This is going to be our stepper motor, 1 piece. There's a 5-volt relay.
Cool. Look right there. That kind of looks like an Xbox shape.
This is called an IR receiver module.
Ooh, that's cool.
Start putting this back in here. This is a temperature and humidity module. So this could like make a sensor to tell you what temperature it is outside.
Ooh.
This
There's that.
is called a potentin. We don't know all the words yet. We're figuring it out.
Kind of looks like a wheel.
Okay, so this last bag. Small button, 5 pieces. 1, 2, 3, 4, 5.
Okay.
Photo resistors, 2. And then diode resistors, 2. And this last bag has the active and passive buzzer.
Ooh, like, I guess it buzzes.
You're silly.
Yes.
Tilt switch. The 74HC595 and the L293D. So we already have the potentiometer. And then RGB 1 piece. That was probably in the bag with the LEDs. Are you watching here, buddy?
Yeah.
NPN transistors.
This long part is kind of hard to see because the background is white and it's probably kind of whitish. It's really hard
Yeah,
to
that's
see.
the one. Okay, it's right there. See this? That little black dot right there and the
Yeah.
2 wires coming out? That's this one
Yeah.
piece right there. Okay.
Okay.
So does everything have a check mark? Looks like we've got everything.
Check mark, check mark, check mark, check mark, check mark, check mark. Check mark, 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 check mark.
What do you want me to check?
Yeah, that's fun. I just check marking all this stuff.
Good,
Looks like all of them are check marked.
good, good, good,
Get
good.
it?
Check mark. I checked. Mark. Get it?
Yeah.
Okay. This is whatever we build today is going to be. Where's the camera at? EPC model number 1. Bought this off Amazon. Pretty cool setup. So, this little whatever. Something like that. Elegoo. On a CD. What am I supposed to put this in? Can we put this in your Xbox?
Maybe.
We'll put it in the computer.
Yeah. That'd be cool if we put it in the Xbox though.
Yeah, no. We're good on that. We got I don't know if there was any sound. Is there sound now? I don't think there was sound because I think I had it muted. I think. Hello out there?
Can you hear us, guys?
There's one person watching. We're trapped in this little box here. We can't get out. Edward, don't leave the box, dude. Get back in the box.
I'm just fixing
The Edward box.
Wait, what?
It's the Edward box.
And it's the daddy box as well.
I'm not in the box like you. Oh, there I am. Hello. Oh, look at that.
So you might get in the box. So good.
My head's in the box. Okay, we're done downloading. It says it's opening when complete.
Yay!
Okay, so
Hello, Robot fans.
Nice. Let's create a new folder.
Do you guys like robots? I bet you guys do. Because we're making one. A great one.
Right there.
Eating this, I'm pretending I'm eating that. You're probably gonna be like, why are you eating that? It's gonna hurt you. Don't worry, guys, I'm not really eating it. I'm pretending to. Boo! Did you ever want a robot kit yourself? You probably did.
Is this Ask the Audience time? Audience? Anything? I can't hear anybody. Hello? I can't hear anybody. Hello?
If you can type to us for talking, make sure you like a robot kit. That'd be great.
Who's watching? Who's watching?
Robot fans, do you like robots? I bet you do. And better than any type of robot. This robot that we're building is going to be awesome. You're probably going to love this video. If you can leave down comments for this video, make sure you do. This video is great.
Nice, dude. Nice. Way to throw that comment link out there. Nice.
Which kind of robot do you like, and which kind of robot would you want? Because I bet you would like one. Leave a comment down below which robot you like.
Trying to be a YouTube star here, man?
Probably. I was wanting to make a video.
Well, you're on a video right now, dude.
Yep.
Okay, so we downloaded that. We got it saved and extracted to the folder. Let's go tutorial 1. So you will select a folder with your language. In that folder you will find a tutorial. Read and follow it. What's our language again?
English.
Okay, English. This is the tutorial. We're opening it.
Yay!
There we go.
Robot fans, have you ever done this before? Leave a Leave a comment down below.
Dude. You gotta practice being on video. It's catching you making all your silly faces over there, dude. You're like. Say look. You're silly.
Yeah.
164 pages, dang.
Oh, oh, oh. We can't read all this in one day.
We're not gonna read all of it, we're just gonna start.
Yeah.
So, let's go.
What? Just kidding, it's me.
Okay, so let's start reading. Our company, established in 2011, Elegoo Inc., is a thriving technology company dedicated to open source hardware research and development, production and marketing, located in Shenzhen, the Silicon Valley of China. We've grown to over 150 plus employees with a 10,763 plus square foot factory. Our product lines range, that says ring, but it's range, from DuPont wires, Uno R3 boards to complete starter kits designed for customers of any level to learn Arduino knowledge. In addition, we also sell... I moved yours over here, dude. In addition, we also sell products of Raspberry Pi accessories like 2.8-inch TFT Touch and STM32. In the future, we would devote more energy and investment to 3D printer products and so on. All of our products comply with the international quality standards and are greatly appreciated in a variety of different markets throughout the world. Official website is www.elegoo.com, and we purchased from Amazon.com. Our tutorial. Our tutorial. This tutorial is designed for beginners. Are we beginners?
Yes.
Yeah, we are, dude.
High five.
Let's do this.
High five.
Oh yeah, we're gonna build robots to save the world. They're gonna take over the world, but they'll probably save it too.
Yeah, I think
take it over, but it's okay.
They're gonna be.
The robots told us to do it.
The robot's gonna be good and bad, both.
You might need to let someone hop up there next to you, dude, or move her chair next to you.
Do you know who she is? She is my sister.
Are you coming to distract us from our robot learning?
No.
Yeah.
And the octopus.
It's hilarious.
Hilarious.
Okay, where were we? Sorry. See, this tutorial is designed for beginners. Are we beginners?
Yes.
High five.
High five.
Deja vu, dude. Deja vu. Okay.
High five, everybody.
Oh, you gotta give high fives from Emma. Welcome to the party. Welcome to the party. You're a beginner too?
Yeah.
You will learn all the basic information about how to use the Arduino controller board, sensors, and components. If you want to study Arduino in more depth, we recommend that you read the Arduino cookbook written by Michael Margolis. Some codes in this tutorial is edited by Simon Monk. Simon Monk is author of a number of books related to open source hardware. They're available at Amazon. They're programming Arduino, 30 Arduino projects for the evil genius, and programming the Raspberry Pi. Dude, this guy wrote a book with 30 projects for the evil genius. Let's do it!
Evil genius.
Customer service. As a continuous and fast-growing technology company, we keep striving our best to offer you excellent products and quality service as to meet your expectation. And you can reach out to us by simply drop a line at service@elegoo.com or euservice@elegoo.com. We look forward to hearing from you, and any of your critical comment or suggestions would be much valuable to us. And any problems and questions you have with our products will be promptly replied by our experienced engineers within 12 hours, 24 hours during the holiday. Oh, this is the packing list. We already went through this and checked off everything, right? Right? Don't see anything there that we didn't already have checked off. They've got active buzzer 1 piece, and we've got 2 pieces. Okay, lesson 0 is installing the IDE. That's what we just downloaded. Emma, you're not allowed to touch any of this, okay? You can come learn with us, but you can't touch. We're not touching any of it yet, right? We're doing a whole bunch of reading on the screen over here. This is just day 1. See, you picking your nose on camera, dude?
No.
It looked like you were.
I wasn't. Don't let Emma take over this video. If you see Emma take over this video, make sure to not let her take it over this video.
She's not taking over the video. Are you paying attention to all this stuff I'm reading? Emma? Yep. What are you doing? Let's power to this supply jack over here. Okay, we're reading stuff. Installing the IDE, the Arduino Integrated Development Environment, IDE. IDE stands for Integrated Development Environment. Can you say that?
IDE environment?
No, it's Integrated
Development
Environment. So the Arduino IDE is the software side of the Arduino platform. In this lesson, you'll learn how to set up your computer to use Arduino and how to set about the lessons that follow. The Arduino software that you will use to program your Arduino is available for Windows, Mac, and Linux. We use Windows, and we downloaded the Windows one. The installation process is different for all 3 platforms. Yeah, let's see. What? Emma, stop. Come sit over here next to Bubba. Come on. Should be what we just downloaded. Software. Computer. It says do all this stuff to go to this website, but then it says also, it it's available with the stuff they provided, which we just opened up there.
What? What?
What's going on over there?
What's going on with this?
Okay, so we want to install it with the exe package. Go to desktop, robot, Windows here. And install this here. This is telling you how to put the program. This part I can do, I think. I hope. Okay, installing away. Oh, nobody's watching anymore. I didn't want to watch you be bored anymore, dude.
Hey.
Look, think you're praising that right. Okay.
But at least I'm still excited.
Yeah.
You can still be bored, but still actually excited as well.
Well, I don't think it works like that.
Well, you can be still excited if you're bored, but in a different way. If you're excited.
Oh, yeah?
But you're still excited.
So it's installing the program now.
Dun, 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 dun. What happened to all your viewers?
I don't know.
Are you busy on something? Probably wished you'd have a robot kit. You can also get a robot kit if you're a grown-up, because grown-ups still learn. My dad still learns. And I try to read things I can. I don't have to sound out that anymore because I. What?
You're silly, dude. We're all proud of you.
Out of control. A brain uncontrolled.
Oh, it's installing, chugging along, coming on down. What to install? It's almost done.
Do you ever want to have a robot kit? I wonder if you did, or if you do. If you want a robot kit, you need to go to this.com place.
What .com place? It's not very good information, man. If you're gonna provide the world with info, you gotta give them the right info.
I'm a ghost.
Hey, why don't you go get me your iPad real quick?
Be right back, guys. Hey.
Oh, how'd he get out of the box? Where'd he go? Edward, get back in the box. Where are you? There you are. That was scary.
I wanted to get out of the box so I could get the iPad for you.
Oh, thank you.
But I had to get out of the box. You want to, you can call this thing a box. Actually, it's a phone, but you can still call it a box. Because the face is in it.
Thank you for your permission, sir. It says, would you like to install this device software? Yes.
Yes. Oh, look. I'm a girl. I'm a girl. Boom! Oh, dang. You might have to look at your phone, Daddy.
Go give me a white charging cord, please.
Okay. I got my box. I got it. Guys, I'm coming back. I got a charging thing for Daddy. See it? It's a white charging thing. Like you know it. You go, Daddy.
Thank you.
You're welcome. Always help people. It's always very kind. Especially if you're working with somebody at a restaurant. Hey.
You're
Welcome
silly.
to the phone. Guys, can you hear us?
You're silly.
Sorry about that, guys. I love everything. What? What's he laughing at? What do you think he's laughing at, guys? Leave down in the comments. What are you looking at?
I'm just looking.
This dude is always funny and crazy sometimes. But he is very creative.
What?
I said you're creative.
Creative?
Yes. They create things. So that.
Oh, create things.
Yes. That's what I mean. Dun 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 dun. Hey. Boom! I'm a girl. Boo! Did I scare you that time?
A little bit.
Even the people, the viewers that are probably going to be watching again, they're watching this video done. Probably going to keep getting scared by me. Always wanted to make a video, you know. I've been in my dad's video one time, but it wasn't a video where I was in it the whole time. He started the video probably before I was even in there. And I always wanted to be in a video with Daddy while starting it. And I always wanted to make my own video. When I grow up, I want to be, you know, so a grown up that can do videos, you know, take videos of me playing games. And that would be nice, you know. Always wanted to do that. Look, people are watching again. I see a one up there.
Don't scare them away, dude. Okay?
Yeah. I always wanted to make my own video. And this is my time to do it. Even I'd be in it when it starts.
High five, dude. That's right.
You remember last time you made a live video? I wasn't in there when you started it.
But you snuck in the middle?
Yeah.
That time? Yeah, I remember. That was cool.
Yeah, but this time, I'd be in the video while you started, and that's the cool part.
Yeah.
I get to be at the very beginning of my own video of us creating a robot.
Yeah.
And that means I can probably, when I grow up, I can probably make videos of me playing games.
Why would you want to do that if you're going to be making videos of building robots?
Well, maybe when this robot gets finished, we can
You think we're only making one robot?
make many.
We got to make many so we can make the one that saves the world, right?
Yeah, but
This is just where we're starting. You can worry about making, you're just focusing on the making movies part. You can worry about that later. Right now we should be focusing on the robot. We're down to here. It says, next the following icon appears on the desktop. We got that bad boy right there.
Yep, we can get him some help.
Let's see.
Ooh.
Okay.
Hey.
This should be all good. Let me double click this bad boy, open it up. Let's see.
Hey. Ah. This guy's helping me out. Ask him some questions.
All right. Program's up and going. We're good. Oh, it said we use the installation package to do it, so we can skip the contents below and go to the next section.
Right.
So, what page was the next section on, dude? Did you write that down?
Maybe that, maybe that, maybe that, maybe that, maybe that, maybe that. What's maybe that mean? I know what it means.
Okay. Add libraries. We need on page 20.
Page 20?
Page 20.
Where's page 20? Do you want to know our dogs? You would know. If you don't know our dogs' names, here we say them real quick. Our first dog is named Jessica. Our second dog is named Kizzy. And we didn't adopt her, so you know we just got it from Grammy people.
Yeah. Okay. Lesson 1. Dang, this is just more computer stuff, man. It says add libraries and open serial monitor. Do you got your serial open?
Yeah.
Oh, different kind of serial, dude.
Oh, I did.
Installing additional Arduino libraries. Once you are comfortable with the Arduino software and using the built-in functions, you may want to extend the ability of your Arduino with additional libraries. What are libraries? Libraries.
This is where you can read.
Nice. Well, we're talking about computer libraries here for this file. See, libraries are a collection of code that makes it easy for you to connect to a sensor, display, module, etc. For example, the built-in Liquid Crystal library makes it easy to talk to character LCD displays. There are hundreds of additional libraries available on the internet and for download. The built-in libraries and some of these additional libraries are listed in the reference. To use the additional libraries, you will need to install them. How to install a library? Using the library manager, to install a new library into your Arduino IDE, you can use the library manager available from IDE version 1.80. Open the IDE, click on the sketch menu, and then include library manage libraries. The library manager will open and you will find a list of libraries that are already installed or ready for installation. In this example, we will install the Bridge library. Scroll to the list to find it, then select the version of the library you want to install. Sometimes only one version of the library is available. If the version selection menu does not appear, don't worry, it is normal. There are times you have to be patient with it, just as shown in the figure. Please refresh and wait. Okay. Alright. Finally, click on install and wait for IDE to install the new library. Downloading may take time depending on your connection speed. Once it has finished, an installed tag should appear next to the Bridge library. You can close the library manager. You can now find the new library available in the Include Library menu. If you want to add your own library, open a new issue on GitHub.
Where's GitHub?
It's on the internet, man. Importing a zip library. Libraries are often distributed as a zip file or folder. The name of the folder is the name of the library. Inside the folder will be a CPP file, H file, and often a keywords text file. Example folder and other files required by the library. Starting with version 1.0.5, you can install third-party libraries in the IDE. Do not unzip the downloaded library, leave it as is. In the Arduino IDE, navigate to Sketch, Include Library. At the top of the drop-down list, select the option to add zip library. Cool. So, what that just said is they've already given us a whole bunch of codes to do all the stuff we're going to do. But there's a lot more. There's new and updated codes out there on the internet that we can download and use ourselves. Maybe someday we can make our own codes.
Ooh, guys, did you hear that? That's going to be nice.
Got some photos of how to make those selections. Got it. Good. Got it. See, manual installation.
Cow.
We won't mess with that at the moment. Arduino serial monitor. The Arduino Integrated Development Environment is the software side of the Arduino platform. And because using a terminal is such a big part of working with Arduino and the microcontrollers, they decided to include a serial terminal with the software. Within the Arduino environment, this is called the serial monitor. Serial monitor says making a connection. Serial monitor comes with any and all version of the Arduino IDE. To open it, simply click the serial monitor icon. Selecting which port to open in the serial monitor is the same as selecting the port for uploading Arduino code. Go to Tools, Serial Port, and select the correct port.
You can move this thing.
Remember what that was called?
What's it called?
That piece right there.
A. Joystick mobile.
To D. Module.
Module.
Module, not a module.
Let's try for that time.
Okay.
Always remembers your name.
Settings. The serial monitor has limited settings, but enough to handle most of your serial communication needs. The first setting you can alter is the baud rate. Click on the baud rate drop-down menu to select the correct baud rate. What's baud rate? I don't know. Last, you can set the terminal to auto-scroll or not by checking the box in the bottom left corner. Pros. The serial monitor is a great, quick, and easy way to establish a serial connection with your Arduino. If you're already working in the Arduino IDE, there's really no need to open up a separate terminal to display data. Cons: the lack of settings leaves much to be desired in the serial monitor, and for advanced serial communications, it may not do the trick. Lesson 2.
In this lesson, I read.
What's the lesson called?
Lesson 2, Blink.
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 Overview.
In this lesson, you will learn how to program your Uno
R3.
R3. Like it, a little closer.
Here, stare at that now.
Right here. Controller board to link the
Arduino's
built-in
LED
and how to download programs by basic steps.
Good job. So what did that just tell us? Do you remember?
That's going to tell us about basic steps.
Well, what words do I have highlighted right there?
Learn how to program. Learn how to program.
We're going to learn how to program our board right there.
Yay.
Our Uno R3 controller. That's this bad boy.
Guys, I'm actually a good reader.
You are. I heard you. You're doing awesome, dude. Component required. 1 Elegoo Uno R3. Got it?
Yep, I got it.
Principle. The Uno R3 board has rows of connectors along both sides that are used to connect to several electronic devices and plug-in shields that extends its capability. It also has a single LED that you can control from your sketches. This LED is built onto the Uno R3 board and is often referred to as the L LED, as this is how it is labeled on the board.
Dude, how did they get that picture without probably touching it?
This is what the board, well, you can touch it, just doesn't need a lot of touch. This is what it looks like when it comes out of the package. Not that big, of course. See how big it is? Edward's holding it there in his hand.
It's not really big. It's
like the size of Edward's hand.
They just got a close-up picture, you know.
Yeah. You may find that your Uno R3 board's LED already blinks when you connect it to a USB plug. This is because the boards are generally shipped with the blink sketch pre-installed. In this lesson, we will reprogram the Uno R3 board with our own blink sketch and then change the rate at which it blinks. In lesson 0, you set up the Arduino IDE and made sure that you could find the right serial port to connect to your R3 Uno board. We didn't do did we do that? No?
Probably not. I don't even remember doing it. Did you ever see us do it, guys?
What's the next section, right?
Tell us in the comments if you ever see us do it.
Dude.
What? It's live. You can comment. We're making an actual video.
Yeah.
So people can comment if they saw anything that we didn't even remember doing. They can comment us if they did see us doing things that we didn't remember doing.
I think we need to go through that sample. Open the serial monitor. Okay.
Blah, 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 blah. You like that?
So we'll open up.
It was
Arduino.
Arduino. We need a URL. Have you ever seen one of these bad boys before? Yeah, you haven't. But if you do have this kit and you've seen it before, good, because you might need this part. Make sure you have a computer and keyboard. And if you're doing it on live, do it so other people can see. You want to hear a knock-knock joke? Knock-knock. But I think it's a little bit hard. Here, I'll tell a knock-knock joke to Daddy, but let's pretend Daddy is you guys. Knock-knock.
Who's there?
Viewers.
Viewers who?
Viewers are watching.
Oh,
Is that funny?
that's hilarious.
Yep. And hopefully you guys laugh a lot. It's good to make Daddy pretend he's you guys. You guys can't talk while the video is going. You have to just watch the video.
They can chat.
Ooh. You can leave down a comment if it's funny or not. If it's funny, great.
Bridge install. Like it says. Okay.
Guys, this is going to be nice. This is going to be awesome. You will actually really want one of these. Since we're on live, you probably want one of these by now.
Bridge installed. Good.
Leave down a comment down below if you want one.
For the zip library, we're gonna get the serial monitor. You got your cereal?
We have lots of cereal, but I think that it's not talking about this kind of cereal and the eating cereal. It's talking about probably something electronic cereal, but it's not something to eat. Guys, have you ever heard of all of this stuff? Probably not. You're probably learning right now. This piece, this is a controller piece right here. Did you ever see this part move yet? It can actually move. This is the joystick part. It might be basic to know. With you, I'm going to have a lots of good time in this video. Make sure you watch this video and pay attention. If you ever see me doing something, leave down the comments down below. If you see me do anything, leave down a comment. Doing anything good. And you know why when I'm drinking I put my hand up? Because I don't want to see any grossness. Hey! What? You can see my face in my mouth now. I don't understand it now. Now, back to our stuff. And have you always wanted one of these? Then you should get one. Since my dad is helping, I bet someone can help you. My dad is also learning. He never got a robot kit before either. grown-ups can still learn today. Because they always learn stuff. Grown-ups can still learn. You know, they can still learn a lot of stuff. My dad is learning something right now.
Yep.
And it's because he never done this before. And you know, how is he not going to let this, you know, kind of break?
Don't.
What?
I can see you.
What? You can see me this way or that way. How are you being careful with that?
Let's connect this bad boy.
How did you do that without messing it up?
I'm just not messing with it, okay?
Oh. Have you ever heard of this thing? This thing is just a bag. You can't use a bag for something. You can't use it over and over again.
So the light's on.
Dude! Guys, you should see these lights. There's a yellow light that's blinking, and there's a green light that's not blinking. Man, you should see this. This is mad. Daddy is gonna love learning still. He's just not a kid still. But even you guys can still learn. You're grown-ups, so you can definitely still learn.
Thank you for your permission.
And if you ever want to learn, go ahead. There's nothing wrong with the learning. Because Daddy is learning. Might be helping me, but he's still learning.
Okay, let's learn. Stop. Okay, let's learn. We selected our port. Something opened up like that. Let's see. Settings. Monitor. 96 baud. Let's scroll. Okay. Back to lesson 2, blink.
Okay.
See the yellow light blinking there?
Yeah.
Well, we're going to stop that from blinking, and then we're going to reprogram it to start blinking again. Okay?
Nice, okay. Guys, make sure you're learning as well.
Says Arduino IDE includes a large collection of example sketches that you can load up and use. This includes an example sketch for making the LED blink. Load the blink sketch that you will find in the IDE's menu system under File Examples 01 Basic. File Examples 01 Basics. Blink. Okay. When the sketch window opens, enlarge it so you can see the entire sketch. Can't really see the entire sketch that way, but okay.
Be right back. Everybody. Still that computer. You can always see me. Getting up and getting back.
Okay, the example sketches included with the Arduino IDE are read-only. That is, you can upload them to the Uno R3 board, but if you change them, you cannot save them as the same file. Since we are going to change this sketch, the first thing that you need to do is save your own copy. From the File menu, click Save As, and then save the sketch as the name MyBlink. We'll save as. We'll do
Look at this thing.
my blink.
Wow, look at it. You should look at this thing. Wow, just look. Look at all those things.
Save it. Okay.
Look at all those circles.
Did that.
Look at this guy. It looks like.
Attach your Arduino board to your computer with the USB cable and check that the board type and serial port are set correctly.
Oh, look at all the circuits. Look at all these parts that are stuck on there.
Good. Okay.
These parts must do this thing.
Checked them. Note. The board type and serial port here are not necessarily the same as shown in picture. If you're using 2560, then you'll have to choose Mega 2560 as the board type. Other choices can be made the same way. We're good on that. See,
Yay.
what's this here? Same port at the bottom of the window. Yeah. Upload. It's putting it on our board.
Yay!
Everything. When it's starting to it's right. It's putting the sketch together now.
Hey, stop popping.
See, the other message tells us that the sketch is using 920 base 10 bytes available on the sketch stage. You should get the following error message. Okay.
Blah, 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 blah. And see from Wales.
Compiling the sketch right now. Done. I didn't get an error message.
Daddy, what are you doing that?
Okay, we're good. Let's see. Okay, so it's teaching us about the code here, okay? Let's see. It says to note that a huge part of this sketch is composed of comments. These are not actual program instructions. Are you looking at me? Reading over here? Rather, they just explain how the program works. They're there for your benefit. Everything between / asterisk and asterisk / at the top of the sketch is a block comment. It explains what the sketch is for. So you see right here,
Yeah.
the / to that, this is all one comment here, okay? It's telling you what the sketch is for. And that says blink. Turns an LED on for 1 second, then off for 1 second. So see that yellow light? It's coming on for 1 second, it's off for 1 second. On for 1 second, off for 1 second. See if we can show the people in our YouTube world. Yellow lights on, yellow lights off. Yellow lights on, yellow lights off, okay?
You see that, guys?
It's on. See. Most Arduinos have an onboard LED you can control. On the Uno, Mega, and Zero, it is attached to a digital pin 13. This is an Uno, okay? If you want to know what pin, okay, we know that. This, okay. So this says single line comments start with / and everything up until the end of that line is considered a comment. Go check on me.
Be right back, guys. I'm back, guys.
Do you need help?
Yep, I think so. I'm back, guys. Don't worry about him. We are taking a little break.
Hey, come here.
Be right back, guys.
I'm gonna step away for a minute, okay? We'll be back. Why don't you sit there and try to read some of that stuff on that screen? Don't scroll around, okay? Don't push anything on my phone. Don't push anything on the surface, okay? If you want to turn on your iPad, you can. It's underneath the computer. But maybe try to read some of those words on the screen. Don't touch anything, okay?
Okay. Dad, you should better step away for a second. I might do something. I'm right here. I'm right next to Daddy's C. That's C. Yeah, I don't know what to do. I don't know. Okay. If you want to, you can just watch the thing for a second. Don't go away. This is kids at YouTube. You might know this. I'm going to see if we can find anything you might like.
How you doing, dude?
Good?
Having fun?
Here. Say hi to the people.
Hi, people.
Mommy's just doing something in the church. Don't worry, guys. I'm here. You watch videos. You might want to watch this instead. Oh, look. And dude, you're gonna love this.
Today I'm looking at a ton of dollar store items sent in by you. That's right. You, the viewers, sent me all these great dollar store items, and I'm joined by Gunner here. We already saw it.
You like this? Have you even seen this before?
If you forget, guys, today
Yeah.
puppies to me. I'm gonna be letting you know whether it's buy it or return it. Now, if you guys are interested in sending these dollar store items for
A buy it or return it.
intention by these viewers is to send me strange, weird, goofy products so that I make fun of them. I'm not making fun of the viewer. In fact, I'm super thankful if they send me a bad product because that's what we're doing here today. It's necessary to say. Even though I have to say it, no matter what you do, no matter how many times you guys want to talk about it, comment that you hate it, you know what have to do this. Pick that subscribe button. No, fella.
Done, guys. Let me see if we can get something better. You might like this instead. You might not want to watch that. Could be something. I don't know what's in there, but I don't want you guys to. You want to watch some Pink Panther? Do you know what that is? You know what that is, guys? Probably not. Probably. A lot of Pink Panthers up there. Alright guys, you wanna watch me play some games? Try to download a game. Can't fully download. Did you know guys, there's Pac-Man for iPad. You wanna watch me play? Alright, I'll be like this. You guys can watch. Click X. Go here. You see? Alright guys. Done guys. My dad's here. Be right back. Back guys. That's my dad.
I'm his dad.
I didn't know where we stopped at, so I just played my iPad. Showed the people some videos as well. And I kind of tried to show them me playing Pac-Man.
What were you playing Pac-Man on your iPad?
Yeah?
Nice. I'm trying to see here. It says single line comments start with // and everything up until the end of that line is considered a comment. The first line of code is INTLED equals 13. And I don't see that line here. I didn't mean to click that. So that's the first block comment. This is a single comment. The setup function runs once when you press reset or power the board. And this, see, the loop function runs over and over again. Void loop, digital write, delay, digital write, delay. Wait for a second. Turn the audio off. Wait for a second. Okay, so as the comment above it explains, this is given a name to the pin that the LED is attached to. Okay, so I don't see that here. Okay. You looking, dude? You getting bored?
Not getting bored.
You're getting bored?
I'm not.
Okay. As the comment above it explains, this is given a name to the pin that the LED is attached to. This is 13 on most Arduinos, including the Uno and Leonardo. Next, we have the setup function. Again, as the comment says, this is executed when the reset button is pressed. It is also executed whenever the board resets for any reason, such as power first being applied to it or after a sketch has been uploaded. The reset button is this little red button right there. See it?
What happens if we push it? Does it reset?
Yep. So the light flickered, showing it's reset, and now it's back on.
Yeah. That's cool. Did you see that? You know, it turns people. Did you see that, guys?
They couldn't see it. They can't see the light. This is where it's over here.
Too bad you can't see, guys. Sorry, guys. You might have to just... Daddy has to pick it up.
Kind of hard for them to see. Press the reset button and the light flickers. Comes back on. Okay. So this is showing... This is this code right here says... Void setup, pin mode. That's what it's doing. When the board resets, gets power, or new code's uploaded, it resets. It does that, and that's what that code makes it do. Is it flickers. Every Arduino sketch must have a setup function. Okay.
Okay.
And the place where you might want to add instructions of your own is between the blank and the blank. I don't know how to Initialize digital pin LED. Void setup. Okay. In this case, there's just one command there, which, as the comment states, tells the Arduino board that we're going to use the LED pin as an output. It is also mandatory for Sketch to have a loop function. Unlike the setup function that only runs once, after a reset, the loop function will, after it's finished running its commands, immediately start over. You remember, put that down, on the Osmo thing, the loop tiles?
Yeah.
And it replayed that part of the beat.
Yeah.
It's the same thing here, and that's what starts right here. It says void loop, and these comments are telling you what each of these lines of code does. When this loop functions, it runs over and over again forever. That's what it's doing right now. It does this first function, which turns the LED on, and it says keep it on for a second. Then this function turns it off. It says keep it off for a second, and then it starts back over. On 1 second, off 1 second. On 1 second, off 1 second. Inside the loop function, the commands first of all turn the LED pin on high, then delay for 1000 milliseconds. 1000 milliseconds equals 1 second.
Oh, cow.
Then turn the LED pin off and pause for another second. You're now going to make your LED blink faster. As you might have guessed, the key to this lies in changing the parameter in the parentheses for the delay command. Ooh. Okay. This delay period is in milliseconds, so if you want the LED to blink twice as fast, change the value from 1000 to 500.
Oh, macaroni.
This would then pause for half a second each delay rather than a whole second. Upload the sketch and you should see the LEDs start to blink more quickly. So it's showing us in this picture here, on this code here, where to change it. Okay, and this is where I already pointed out to you where it says delay the 1000. It's delaying 1000 milliseconds. So we're going to change that to 500.
500.
And then we're going to change that to 500. So the on and off cycle is only 500. So let's show our viewer. Right now we've got 1 second on, 1 second off. Okay?
Okay.
Okay. So we're rewriting the code here. Let me show them where we're. This is our little Arduino application where we're rewriting the code.
Thing about it.
Okay. Okay. So we
Sorry about that, guys.
got the code rewritten. Let's verify. It's compiling the sketch real quick. Coding for programming, there's a lot of little things. All these little marks mean something. Did you type something, dude?
No. I didn't type anything. Did you ever see me type something? I didn't hear any typing. I got my iPad.
Okay.
Weird. When I got my iPad, I don't remember me ever accidentally getting my arm on the keyboard. I don't remember that happening. Guys.
So you're telling me you did put your arm accidentally on the keyboard?
No, I didn't.
It looks like, dude, it's okay to say you did.
I can't remember if I did or not.
Stop. It's okay. We're moving on. Sorry.
It's okay.
Okay. So I'll remove that line and we'll verify again. So that's what I was just saying. All these lines all these symbols, they all mean stuff, and if it's not typed perfectly, the codes don't work. And whatever happened, there was 4 letters there that were messing up the whole code. Let's see what happens when we take those 4 letters off. Still 1 second on when we haven't uploaded the code yet. We're still verifying that it's right.
So where guys, another word and just chilling.
Chilling like a bored guy.
Hey, I said I was not bored.
We're doing the coding part, dude. Just gotta be able to do a lot of computer stuff to do coding. It's a lot of time looking at the computer, making sure all those lines are right. Okay, looks good. So we can upload. Let's upload.
Upload.
Let's see what happens. Okay, it's compiling it first, and it's gonna upload. Remember how it blinked real fast when it reset?
Yeah.
That's how we know when it's uploading. So, well, it's uploading. Now look how fast it's blinking. Half on, half off. Half on, half off. Oh, cool. You see that? See how fast it's blinking now?
Yeah, that's cool.
You want to make it blink even faster?
Yes.
Let's go faster.
Dude, hey, made it even faster. Upload, 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 upload.
It's gonna upload it. Okay. Bam.
Holy cow,
Blink,
that's even
blink, 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 blink. Okay, so there we go. Bam! That was our first lesson, dude. We just learned how to program a blinking light. And I could show you some stuff too here. Let's...
Yeah. High five, guys.
High five. We could do this where we see this is the on light. So let's have it on for 2 seconds
2 seconds.
and then off for half a second. See what happens there. If 1,000 milliseconds was 1 second, how many milliseconds do we need for 2 seconds?
2 milliseconds.
How many look at that. On for 2, off for a half. On for 2, off for a half. If 1,000 milliseconds is 1 second, how many milliseconds do we need for 2 seconds?
2,000.
That's right. Okay. So that's our blink code. We'll leave it like that for now, okay?
Okay.
So lesson 3 is called LED.
LED.
In this lesson, you will learn how to change the brightness of LED by using different values of resistor. Ooh.
Ooh. What? Hey, why you stop touching me? And keep your head down.
Okay, for this one,
When I did
we're
that.
gonna need the Uno R3 board that we got going there.
Yep. And you need the LED lights.
We need one 5mm red. So
Oh no.
I'm gonna assume
Oh,
these
no.
are all 5mm.
Look at this thing. This is what it looks like right here.
We need one 220 ohms resistor. Okay, let me
Might be hard.
this up here.
The back part might be hard to see on the camera. It has this little metal silver part on the back of it. Sorry you can't see it, guys. It's a little bit hard on camera. It's a little bit hard.
So
It is red light.
don't take any of those off. But you see it says 1K.
Okay.
We need one 1K resistor. We need one 10K resistor.
Okay.
We need one 220 ohm resistor. Let me see if I can find that. Looks like we'll be using a lot of 220 ohms because there's a whole bunch of those. Okay. Then it says we need 2 male-to-male wire jumper wires. Okay. I'm gonna cut that zip tie and run that there. There's one.
What happens if you put this part on this?
Don't. Nothing.
Nothing.
But we're gonna learn how this stuff works, so if you just chill. It's about to give us a lesson.
I want to learn how this thing can turn on. That'd be cool. And a yellow
Well,
one?
what did this just tell us? It told us we're gonna learn how to change the brightness of an LED. So that means we're gonna turn it on and learn how to control it. The last thing we need is the breadboard.
Yeah,
And this is going to introduce, you need to pay attention. You had questions about this, right?
Right.
And this is about to tell us about what this is and what it does, okay?
Okay. Let's open the breadboard up. Yeah, breadboard. Hey, I think I've seen one of these before.
I've had a couple. You've seen them. A breadboard enables you to prototype circuits quickly without having to solder the connections. Below is an example. Breadboards come in various sizes and configurations. The simplest kind is just a grid of holes in a plastic block. Inside are strips of metal that provide electrical connection between holes in the shorter rows. Pushing the legs of 2 different components into the same row joins them together electrically. A deep channel running down the middle indicates that there's a break in connections there, meaning you can push a chip in with legs at either side of the channel without connecting them together. Some breadboards have 2 strips of holes running along the long edges of the board that are separated from the main grid. See these 2 strips separated from the main grid? These are the main grids. This is that channel they just said runs down the middle that breaks the connection.
Yeah.
These are the strips on the edge. These have strips running down the length of the board inside and provide a way to connect a common voltage. They're usually in pairs for plus 5 volts and ground. These strips are referred to as rails, and they enable you to connect power to many components or points in the board. Okay, so putting them here is going to put power to all this, okay? While breadboards are great for prototyping, they have some limitations. Because the connections are push fit and temporary, they are not as reliable as soldered connections. If you're having intermittent problems with the circuit, it could be due to poor connection on a breadboard. LED.
LED.
You're not messing with those wires, right?
But I'm not.
Don't mess with them. See, it's telling you in the picture. See, so LEDs make great indicator lights. They use very little electricity and they pretty much last forever. In this lesson, you will use perhaps the most common of all LEDs, a 5mm red LED. 5mm refers to the diameter of the LED. Other common sizes are 3mm and 10mm. You cannot directly connect an LED to a battery or a voltage source because 1, The LED has a positive and negative lead and will not light if placed the wrong way. And 2, an LED must be used with a resistor to limit or choke the amount of current flowing through it. Otherwise, it will burn out. Now, see that picture there?
Yeah.
You see the wire that's a little bit longer?
Yep.
That's showing that's the positive wire. And the shorter wire is the negative wire. And that's all about power. Positive and negatives are all we'll learn as we're going. It's about power, okay?
Okay.
If you do not use a resistor with an LED, then it may well be destroyed almost immediately, as too much current will flow through, heating it and destroying the junction where the light is produced. There are 2 ways to tell which is the positive lead of the LED and which is the negative. Firstly, the positive lead is longer. That's what we just saw, right?
Yeah.
Secondly, where the negative lead enters the body of the LED, there's a flat edge to the case of the LED.
Blah, blah, blah.
Oh.
Just so LED.
Okay. If you happen to have an LED that has a flat side next to the longer lead, you should assume that the longer lead is positive.
What?
Okay, whatever. Resistors. That's what these are right here. These are resistors.
Resistors.
As the name suggests, resistors resist the flow of electricity. The higher the value of the resistor, the more it resists and the less electrical current will flow through it. We're going to use this to control how much electricity flows through the LED and therefore how brightly it shines. Let's see if we can.
Find it. Sorry guys, you can't see it. You can't see my face well. Sorry. Right, we're back. We're back. Still watching?
It's
Still
our
watching?
breadboard.
Breadboard.
There's
Bread
some
boy.
resistors, more resistors, more resistors, our LED, and our.
The wires.
We haven't gotten to those yet. We're talking about resistors right now. So, the higher the value of the resistor, the more it resists, and the less electrical current will flow through it. Okay? But first, more about resistors. The unit of resistance is called the ohm. Ohm. Which is usually shortened to this symbol here, which is the Greek letter omega. Because an ohm is a low value of resistance, it doesn't resist much at all. Let's see. Show you. That symbol right there.
Ooh.
Okay.
Almost like human legs and feet almost. Yeah, it looks like it.
Because an ohm is a low value of resistance, it doesn't resist much at all. We also denote the values of resistors in 1,000 ohms and millions ohms. These are also called kilo ohms and mega ohms. So the K omega is a kilo ohm, the M omega is a mega ohm. In this lesson, we are going to use 3 different values of resistors. 220 ohms, which is this one here.
Yep.
They just have it labeled 220 for us. The 1K ohm, which is this one here. They have labeled 1K for us. And then the 10K ohm, which is this one here. These resistors all look the same except that they have different colored stripes on them. These stripes will tell you the value of the resistor. See on the 220 we got brown, black, black, red, red. On the 1K we have brown, red, brown, black, brown, it looks like.
Oops.
And then on the 10K we have brown, black, red, brown. So, the red and brown's kind of hard to tell the difference of, but
Yeah.
none of these match because let's see, they're all different. Okay.
Oh.
The resistor color code has the 3 colored stripes and then a gold stripe at one end. So sorry.
That's okay. I can see it. Red, brown, red. Oh yeah.
One of those is supposed to be gold. See, okay, look here.
One is supposed to be gold.
We can study that some other time. See, unlike LEDs, resistors do not have a positive negative lead. They can be connected either way around. If you find this approach method too complicated, you can read the color ring flag on our resistors directly to determine its resistance value, or you may use a digital multimeter instead. Okay?
Okay.
So this is kind of laying out the connection schematic for the breadboard. It looks like. No, this is the Arduino board. It's showing us that. Something.
Yes, I really like board.
Well, you see here on the sides here, it's got all these names. It says reset, 3.3 volt, 5 volt. Those aren't matching what's on there. Oh, that's 3. Okay. Okay. So, see what it's telling us to do here?
Yeah.
We're about to do some connections here, okay?
Okay.
Let's do the LED first, okay? It's saying
Put on the board. Breadboard. Board. It looks like.
okay. It's saying put the negative side into the power, okay?
Okay.
And then fuzz it out. Okay. Say, and then it's saying take the 220 ohm resistor, pull one off here, 22 ohm resistor, run it from that same line to the positive side of the power. So we'll do it here.
All the way to there.
We don't want any of these metal things touching them. Okay, that's how you short them out. Okay.
Okay. What goes with
Let me
next?
show here. And now we're going to put power from the Arduino board to that, okay?
Okay.
So it's saying go from the ground to the negative side of the breadboard. So if you see here it's labeled ground, it's kind of, let's see how focus we can get.
Do you see that, guys? Hope you can.
I don't think they can read the words. Go to the ground.
Can read the
To the-
words.
To the negative, and it says go from the 5 volt to the positive.
Okay.
5 volt. to the positive. Bam. See that?
Yeah. Oh my God, there's a red light.
Yeah, if you weren't sitting there looking at your arm, you would have seen it come on. Okay.
Okay.
So it says,
Yeah, that's cool. You want to show the camera, maybe?
they can see it. You can see it right there. See it? It says the Uno is a convenient source of 5 volts, which we will use to provide power to the LED and the resistor. Don't touch any of that. There's electricity going through there. You do not need to do anything with your Uno except to plug it into a USB cable, which we have. With the 220 ohm resistor in place, the LED should be quite bright. Looks pretty bright, huh?
Yeah.
If you swap out the 220 ohm resistor for the 1K resistor, then LED will appear a little dimmer. Finally, with the 10K ohm resistor in place, LED will be just about visible. Pull the red jumper lead out of the breadboard and touch it into the hole and remove it so that it acts like a switch. You should just be able to notice the difference. They used the red, they didn't specify what jumper we had to use, but still. At the moment, you have a 5 volt going to one leg of the resistor. Let's see. Okay. Which one did they use for red? Red was their positive. Okay, so pull this out.
Going out.
Let's see. It says pull the red jumper lead out of the breadboard and touch it into the hole and remove it. So it acts like a switch. Bam. Let's see. We got the power pulled out, so now I can take 220. Let's do 1K. Okay, let's see how bright it is now.
Shake, shake.
Which side is
That's not right.
not so bright. Okay,
Damn.
and that was this one. Right?
Yeah.
1K. So we'll take a 10K, and it says it's going to be even less bright now.
Oh my God. It's science. Switch off.
It's like barely on.
Oh, it's barely on. And it looks like it's running out of power.
Yep.
Kind of.
We'll go back to the first one, the 220 ohm.
Is it touching? No, not touching.
It's bright.
Oh, we're right there.
Okay. See, it says at the moment you have 5 volts. That's this jumper here from the board, okay?
Okay.
We have 5 volts going to one leg of the resistor, which is right here, okay?
Okay.
The resistor's cutting that 5 volts into whatever. See, it's going to the positive side of the LED, and the other side of the LED is going to the ground, okay? However, if we move the resistor so that it came after the LED, as shown below, the LED will still light. They move it to the negative. Okay. Probably want to put the 220 ohm resistor back in place. It does not matter which side of the LED we put the resistor as long as it's there somewhere. What does that mean?
Hi guys, I'm back. What? those lights.
Okay.
It's the lights.
All right. So we just finished lesson number 2. What did we learn?
About these things.
What are those things?
LED lights.
What's this thing called?
Oh. Yeah, what was it? I might need to take a thing. There's the name. 220.
It's 220 ohms.
Yeah.
But what's it called?
Resistors.
What, dude, you just said the word after me a minute ago. Resistors?
Resistors.
Resistors?
Resistors.
Okay. And the higher the value, the more power they resist.
Yep.
That's why when we resisted 10K, bless you,
Thank you.
the light was super dim.
Yep.
When we resisted 1K, it was a little brighter. When we resist only 220, it's super bright. Because 1K means 1,000.
Yeah.
So 220 is less than 1,000, right?
Right.
Bless you. And then 10K means 10,000.
Yep.
And 10,000 is more than 1,000, right?
Yeah.
And 10,000 is more than 200, right?
Right. Ooh. Ah.
All right, and then this jumper coming from the 5 volt is the power, and this one here is the ground. This is all called a circuit, what we've just created here. Okay, why don't you say your goodbyes? We're gonna pause for a bit today, okay?
Okay.
We've done. We did like 3 lessons. Only 2 of them were the stuff that we programmed that blinking light. Remember?
Yeah.
And then we learned some stuff with the resistors on the breadboard, right?
Right.
So we'll call this EPC model number 1-1, lesson 1.
Yeah.
Okay?
Okay.
We really did 2 lessons, but you know, until we get through all this and get done building, we're still working on model 1.
Yeah.
The style hasn't changed yet.
Yeah.
Bless you.
Thank you.
You're welcome. Excuse me. Maybe we can get back to some more of this later this evening, okay?
Okay.
We're going to do a couple more lessons before bedtime, alright? Sound good?
Yep.
Alright, so
Bye,
let's disconnect
guys.
the power from the board. I can watch us disassemble.
Okay.
Let's do that. Take those. We'll unplug the power from our Arduino board.
Juno board.
Shit. All the reviews online said once you take everything out of the box it comes in, it never goes back in the right way. So have to be careful with all this. Okay. I'll find another box real quick.
Whoa! This case right here is cool. Very cool.
It is very cool. Just take that there.
I like it.
All right, that was EPC model number 1, lesson 1. We'll be back for lesson 2 later tonight. Have a